Let's set A equal to lowercase letters a, b, c, d, e, f, g, h, i. For part A, we want to determine how many subsets does set A have. For part B, how many proper subsets does A have. And part C, how many subsets does A have that include the elements A and I. So first thing is we want to talk about is the first part. If there are n elements in a set, 2 to the power of n subsets can be formed. So we need to figure out how many elements are in this set. When we count, we get 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 elements in A. Therefore, we would let n equal 9. So this means that A is going to have 2 to the 9th subsets. So we want to evaluate that expression. So in order to evaluate that expression, we're going to go ahead and do that on the calculator. If we take 2 to the 9th power, then we get 512. Therefore, 2 to the 9th is 512. So we would say that A has 512 subsets. Now for part B, it says, how many proper subsets does A have? Now, to find how many proper subsets A has, we first find the number of subsets of A that are not proper. Now, the only subset of a non-empty set S that is not a proper subset of S is the set S itself. This means that every non-empty set has exactly one subset that is not proper. Now, since A has 512 subsets and exactly one of them is not proper, then A would have 512 minus 1 proper subsets. So evaluating this expression, 512 minus 1 gives us 511, and therefore we would say that A has 511 proper subsets. Now let's go back up to the last question. It says, how many subsets does A have that include the elements A and I? So we want to describe one way it would be possible to find all the subsets of A that include the elements A and I. Now, first and foremost, we want to remove the elements A and I to form a new set B. And then we want to find all the subsets of B. And then to each of those subsets, add the elements A and I. So this means that the number of subsets of A that include the elements A and I is the same as the number of subsets of B. Since there are 9 elements in A, and the elements of B are all the elements of A except A and I, then there are 9 minus 2, which is equal to 7 elements that are in B. Therefore, this means we can say that B has 2 to the 7 subsets. So let's go ahead and evaluate that. 2 to the 7th gives us 128. So evaluating this expression, we get 2 to the 7th, which is equal to 128. And it follows that B has 128 subsets. And so A has 128 subsets that include the elements A and I.